And then there's a big drop-off to the year 2007, and whether or not it's a bombing. A generic IED is actually a surrogate for INB because most bombings are coded in our data set as generic IEDs. There's nothing special about them written about in the newspapers, so they go in as a generic IED. So these variables are pretty much the same variable. Incident time is in the evening. That has some importance. Other IEDs, again, as part of that. Epoch 4 kind of lines up with year. That's a period of time in which there were certain systematically similar things going on in the Philippines, and it kind of lines up a little bit with the year 2007. And then, you know, the rest of the variables, the different months, whether it was a landmine or so on. This is the place whether it was in a commercial place, a market, or retail area, or an office building. It's commercial, yeah, office building. Had some importance, but obviously these things are much less important than what's going on up there. Okay, so having milked cart for quite a bit, we felt comfortable then to go to random forest and see if we couldn't kind of inch things up a little bit. There actually are a number of things that you need to worry about a little bit when you're setting up an RF run, as I'm sure you know by now. And one of them, of course, is how long do you let the sucker run? We actually went out to 1,000, and basically it didn't change between 500 and 1,000. And basically, right, it doesn't look like it was changing much certainly from 100 on. But so you do need to set that. There are some versions, I don't remember which one, R or Weka, where the default is 50, and I think there's one of them where it's 10. You really want to change those, the number of trees that are grown to be part forest. The other thing you have to set, which is really crucial, is the number of predictors which are selected randomly, the set of predictors from which the splitter is picked. The size of that cell is default in some areas is the square root of the total. We had 87, square root 9, and we tried 9. Now, before I go on, let me just tell you, we've done a bunch of these things, and quite often that default works like a charm. It's beautiful. Data set after data set, I've used the default, and then you try to go one off the default, and you're in deep trouble. So the default does work really, really well, except not here. I was kidding Josh that he did what did I call it? A grid search, yes. Well, he tested, I don't know where he started, 5, 6, 7, 8, 9, 10, and so on up to 50 different variables. And this is based on picking 15 from a set of 15. So 15 variables are selected each node to form the set from which the splitter is selected. Okay, that's two of the three things. Yeah, that's all right. Let's keep going. The weights for the a priori group membership. Just like here, the a priori, the prior probability of group membership, you do need to set that. And here we set it to be equal to the learning data set probabilities, and that worked best for us here. When we tried to be really clever and to augment the lesser groups, it shot our accuracy to bits. I mean, really bits. I mean, way up. We could hardly beat flipping a coin. So this is just using the original learning set probability levels as the priors. Location, 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 the same three locations in the same order. There's nothing surprising here, I don't think. Remember, Epoch 4 and the year 2007 are about the same. And generic IED and bombing are essentially the same variable. So at least in terms of the important variables, the big three and then relatively a smattering of others didn't change. Random forest gave us about the same picture. It's what's really important. I absolutely adore this, the proximities. Now this chart boggles my mind, so almost the end. Oh. I was thinking ahead to the hour. Oh my gosh. Okay, but we will go on. Even more interesting, the heat index, the heat map. You see, we actually had some luck predicting the ASG. We had a lot of luck predicting the NPAs. We didn't do very well trying to predict the second group here, which was the MILF. These are in order: Group 1, Group 2, Group 3, the big one, NPA, and then the other group. Most of the other group got predicted into NPA, hardly any. There were a few of them that got predicted into the fourth group over, which is the NPA group. Let's look at it with multi-MDS. And these were the first two. You just take the proximities, and we just let RF do its thing. And it, you can see with the first two dimensions, the three groups show up really nicely. The green is NPA. This one's kind of mixed. Here's the ARMM down there in Mindanao. If you look at the third dimension, it really doesn't help things very much. Kind of spreads things, smooshes things around. Even in looking at group, we still basically have three groups. Now we're back to three groups. But then when you throw in the fourth dimension, isn't that beautiful? Look at that. We now have four groups. They just pop right out at you. The error rates down here at the bottom, we're running 19 to 20% error on the traditional classification things. CART dropped it down to 16. Remember, we were just working with that 72%, the idiot approach. So we only had 28% error to beat, I guess. So going from 28 down to 19 or 20 is a pretty good deal. I mean, remember, these are the harder ones to predict. And then going down to 16 with CART, that's actually a sizable drop. Out of that 28 points, you're picking up another 3 or 4. And then random forest gave us another 2.5 roughly percentage out of the 28. It was just really pretty. We really like this. To us, if this is good, then obviously better and best, right? Josh, real quickly, I understand we're out of time, but do you want to go? You want me to finish? You finish. You're supposed to finish, because this is substance now, I guess, a little bit.
All right, I'll finish this up real quick. Generally speaking, one of the major benefits of this wasn't just picking out the classification schemes that predicted best. It was sort of proving the viability of two things. One, the approach to predicting culpability using classification techniques, and secondarily, the practical application of our data, which is something that we've been trying to do more and more. We feel that was pretty darn successful with this, and that we have pretty high accuracy ratings. We can see that naive Bayes and multinomial logistic, with their respective error rates, outperform the simplistic scheme, which is just classifying everything in the modal category. But CART and random forest outperform both of those substantially, random forest being the best in terms of overall error. So to sort of bring everything back home, we think that it offers significant accuracy, random forest particularly, over the other methods attempted. And why that's important for us isn't just the fact that we can do it, but because we can get important variables, because we can see other things, it actually makes it easier for the analysts to make determinations themselves. Because at the end of the day, you can't rely on any technique to make the decision for you. This allows them to make much better educated decisions in terms of in terms of the culpability of a given event. Additionally, in the future, we were talking about doing things like combining different techniques to improve accuracy, using variable importance as a way to weight variables and other types of analysis is one idea. There are some others. Again, with the end goal being utility by analysts. And then finally, we had some success, just sort of our props to Salford. We did try random forest, the algorithm, in the random forest product, Weka has an implementation as well. And we found that there are significant increases, particularly in speed and memory usage over Weka. We kept having to reset our memory. In addition, getting visualizations out of R, which is what it's built for, wasn't too terrible, but it was obviously much simpler using the Salford Systems product. So in terms of output and speed, it was much better for us. So in conclusion, we thought it was pretty successful, and thanks a lot for your time.